Welcome to the sixth episode of the series. Today, I want to delve into Bayes' theorem, a concept that's fundamental in both probability theory and statistics. This theorem is a powerful tool for updating our beliefs or probabilities about a hypothesis or event when we receive new evidence. Let's break it down and explore why it is so valuable. At its core, Bayes' theorem is based on conditional probability. It's expressed as the probability of an event H happening given the another event E has already occurred. The formula looks something like this. In simpler terms, it calculates the probability of a hypothesis H being true given some observed evidence E. But to fully grasp this, we need to understand the key terms involved. So let's talk about the key terms in Bayes' theorem. Prior probability. This is where we start. It's our initial belief in the likelihood of a hypothesis based on historical data or general statistics. Then we have likelihood probability. This probability represents the chance of observing specific evidence, given that the hypothesis is true. It is essentially the probability of seeing the evidence when the hypothesis holds. Then we have evidence probability. Calculating this is often the trickiest part. It's the total probability of observing the evidence, considering all possible causes. We have to account for all scenarios. Then we have posterior probability. This is the magic number, the updated belief. It's the probability that the hypothesis is true, given the observed evidence. Bayes' theorem calculates this using the prior probability, like likelihood probability and evidence probability. Let's now discuss an example on medical diagnosis. Let's apply Bayes' theorem to a practical scenario. Imagine a patient with symptoms E and we want to estimate the probability of a specific medical condition H. We start with our prior belief based on general statistics. We consider the likelihood of seeing these symptoms if the condition is present. The tricky part is calculating the evidence probability, which accounts for all possible causes. Finally, we calculate the posterior probability or updated belief in the likelihood of the patient having the condition based on the symptoms observed. Bayes' theorem is an essential tool for making informed decisions when we need to update our beliefs. With new information, I hope this example clarifies the concept for you. Feel free to share your thoughts and thank you for tuning in to this episode. Stay tuned and connected for more enlightening episodes.